In this last video lecture, we are going to discuss two-factor or two-way analysis of variance with the use of the randomized block design. So you might have remembered in the last video, we were able to analyze the differences, or we were able to compare the means of these three samples representing three populations using what we call as analysis of variance instead of the t-test. And that's because analysis of variance really minimizes our alpha or type 1 error instead of using several t-tests to compare three populations. So we also call that as one-way ANOVA because there was only one source of variation that we were looking at. And in this case, that's the year level of the college students, how it affects their sleeping time, for example. So what if we consider another source of variance, not just the year levels of the students? What if we'll add another criterion, in this case, course? So you might notice here in the rows actually represent data from students of specific courses, from BS Biology to Mechanical Engineering. And now it's important for us to get the mean not just of the columns, but also of these rows. So here they are. Okay? And it's important to note that the means of the rows, which are these, and the means of the columns, which are these, have the same overall mean, which is 3.28. So the rows are also known as the blocks. So here we have 6 blocks, or 6 rows, and 3 columns. Okay, so we now have two sources of variance: the year level of the college student sampled, that's in the columns, and the courses of the college student sampled, that's in the blocks. So this time, we are now going to use what we call as two-factor or two-way ANOVA, specifically with no replication. Okay, so why two-factor? Again, because there are now two sources of variation. And why no replication? Because if you notice, when we sampled a BS Biology student that's also first year, we only got one of that student. Okay, and when we sampled a nursing student that's in third year, we also just got one sample for that particular type of student. So there is really no replication here. Okay, so that's why we are going to use two-factor ANOVA with no replication. So instead of showing you the manual solving of the SSEs, the SSTs, etc., let us use Microsoft Excel right away to come up with the results. So you might want to input the data shown here with the proper labels in your Microsoft Excel. And once you've inputted the data and the labels, you then go to data and then to data analysis, and then choose ANOVA, this time two-factor without replication. So you double click on that one, or you click OK, and this dialog window is gonna pop up. Okay, so This is pretty straightforward here. You click on the range for the cursor to appear, and then you highlight all of the data, including the labels. Okay, so take note, Excel doesn't ask anymore if labels are included or not. So Excel will already assume that the labels are always there. Okay, so we are going to set the alpha at 0.05. Okay, and then your output range, click your output range, and then choose a particular area in your sheet to insert the output, and then click OK. And then Excel is going to present to you two tables. The first table is a summary of the descriptive statistics like the average or the means and then the variances, similar to what we did a while ago. But the more important table is the one at the bottom, the one that's labeled ANOVA. Okay? So Excel uses the term rows here, but that's really also our blocks. Okay? And if you notice, the degree of freedom for our rows or blocks is 6 rows minus 1, so we have 5. And for the columns, we have 3 minus 1, or 2 degrees of freedom. And then you focus your attention on the last 3 values to the right. Okay, the F value, the P value, and the F critical, or the boundary of the critical or the rejection region. Okay, so in this first case, we are presented by Excel with the F P value and F critical values for the blocks or the rows. Okay, so we are going to analyze this separately. First, the blocks. And then next will be the columns. Okay, so for the blocks, our critical value is at 3.32. Okay, that's to the rightmost part of our F distribution. Okay, that means that to the right of that is the rejection region. And then the F value that we got here is 3.49, which is within the rejection region. Okay, so we can already say here in this particular result that we will be rejecting our null hypothesis. Okay, so I forgot about the null hypothesis a while ago, but in this case, we say in our null hypothesis that there is no significant difference between the different students in terms of courses, okay, in their average sleeping hours at night. And because our F value is within our rejection region, we say that we reject that null hypothesis. Therefore, in terms of blocks or rows, there is a significant difference between the average sleeping time of a BS Bio student from a nursing student, from a psychology student, from a chemistry student, from a math student, and from a mechanical engineering student. So there's a significant difference. Now, in terms of columns, okay, so what should be the null hypothesis here in terms of columns? We can say that there is no significant difference between the average sleeping hours of a first year, from a second year, and from a third year student, or between those students of different years. But because our F value is well within the critical region, Okay? We therefore reject that null hypothesis, and instead we say that there is a significant difference between the sleeping hours of first years, second years, and third year students. So you notice here in ANOVA two-factor, we are formulating null hypotheses for each of the factors. Okay? First, in this case, for the course factor, there is a difference. That's our conclusion. And then second, for the year level factor. And our conclusion still is there's a difference. Okay. So, and what's more, if you look at our p-value here, our results are highly significant statistically. So the difference now between one-way and two-way ANOVA with no replication is that in getting the sum of squares total, you don't only get the sum of squares between columns, you also need to get the sum of squares between blocks. And then the sum of squares error is going to be obtained from the sum of squares between blocks. So now let's look at this next example. So I have retained the values here, but I have changed some of the criteria, specifically the males and the females here instead of the courses. So you notice here we only have two blocks now. One block for the males and one block for the females. And that's really because we are now replicating, okay, our observations. So for example, for a first year male student, we have sampled here 3. So we have replicated 3 times. And that's also true for a female third year student. We've also sampled here 3 times. So in this particular example, we are now going to use two-factor ANOVA with replication. Okay? And what will be our null hypothesis here? Okay, we can have several hypotheses here. First is that there is no significant difference between the sleeping hours of males and females. That's 1. Number 2, we can have a null hypothesis stating that there is no significant difference between the sleeping hours of a first year, second year, and a third year student. And of course, in a two-factor ANOVA with replication, it's important to take note also of the interaction between your blocks. So your third null hypothesis might be that there is no interaction between the males and the females in terms of sleeping hours. So because there are now 3 observations per sampling here, we are going to get the means of those. Okay, so we can have a table now that looks something like this. Okay? And because I mentioned about interaction a while ago, okay, it's important to take note of the interaction between our 2 blocks, the male and female block. Okay? And why is that important? Because if there is an interaction between the 2 blocks, the male and the female block, then whatever result we get from Excel later on might not be 100% reliable because we have to account first for the interaction happening between our blocks. But if the interaction between the blocks is not significant, meaning to say there's no interaction, then whatever result Excel will give us later on in terms of the F-test, we can already end with that right away without analyzing for the interactions. So in this case, our two blocks would be the male and the female block. So let's see if there is an interaction between the sleeping hours of males and females. Okay, so I have a question here. Do the male sleeping hours remain consistently above those of females? Because if that's a yes, then there is an interaction. Okay, but if that's a no, then there is no specific trend between the two sexes sleeping time. Okay, so let's look at this. So remember a while ago in the table we got the means, okay, per portion of the block. So for first years, male and female, they're the same. For the second years, the male sleeping hours is above those of the females. And for the third years, the male sleeping hours is below those of the females. Okay, so now if we take a look at this, is there an interaction between the males and the females' sleeping hours? If you see a pattern, then there's an interaction. But if you don't see a pattern at all, then there's none. And obviously here, in the first year observation, they're the same. In the second year observation, the males is higher than the females. And in the third year observation, the males is lower than the females, which is more or less random. Okay? The male sleeping hours, for example, is not consistently above the females or the other way around. And therefore, we say here that there is no interaction between our two blocks because there's no pattern at all that we see here. Okay, so let's continue. So in Excel, let's try this in Excel. So first you need to input this particular table. It's very important on how we input our table for two-way ANOVA with replication. Okay, so we have our columns here, and then we have our rows. Okay, so technically there are 6 rows, but there are only 2 main rows, one for male and one for female. Each of them have 3 rows. Okay, so after this, you then go to data and then click data analysis and then choose ANOVA 2-factor with replication. Okay, so once you've chosen that, a dialog table will appear. Okay, and again, Excel doesn't ask us anymore if labels are included or not. Okay, Excel will assume that you've placed the labels. So click for the cursor here to appear. And then once that cursor appears, highlight all of your data, including the labels. Okay, and then set your alpha to 5%. And then click the output range. And wait for the cursor. And then choose the part of the sheet where you want the output to be presented by Excel. And then click OK. So you're going to be presented with these 2 tables. The first table again is a summary of descriptive statistics. And the more important table is the second one, the one that's labeled ANOVA. Okay. So in terms of sample, the sample here, by the way, will be the rows. Okay, and in terms of rows or sample, we only have 2, male or female. So the degree of freedom is 1. Okay, now let's look at the F value, the P value, and the F critical values. Okay, I will not anymore draw the F distribution, but it's very obvious here that our F critical is way to the right, okay, way past to the right, and our F value is well within the acceptance region. Okay, so we say here in terms of rows that there is no significant difference between the sleeping hours of males and females. Okay? Or we accept our null hypothesis. Now, in terms of columns, we have 3 columns. Our degree of freedom is 2. Okay? Our F critical is at 3.88 and our F value is way beyond that to the right. Meaning to say, our F value falls within the rejection region. And we will therefore reject our null hypothesis. Therefore, we say that there is a significant difference between the sleeping hours of first years, second years, and third year students. And it's quite obvious in the means that we have here. They're quite different. What's more is that this result is highly significant statistically. And if we compare that with our result from the rows, which is 0.83, this is not statistically significant. And last but not the least, in ANOVA 2-factor with replication, there is an analysis of the interaction, which we did a while ago graphically. Now we see that the F critical for that is at 3.88 and the F value is 0.904, okay, which means to say that there could be an interaction. But again, if we look at the p-value, it says that this interaction is not statistically significant. Okay, so therefore we can still go back to saying that there is no significant interaction between the sleeping hours of males and females. So, to cap up everything, what can we say here? We can conclude here that there is a significant difference between the sleeping hours of first years, second years, and third year students. And we can also say that there is no significant difference between the sleeping hours of males and females. And lastly, we say that there is no significant interaction between the sleeping hours or between the variables males and females. So this is now the procedure for two-way ANOVA with replication. Not only did we get the sum of squares between columns and the sum of squares between blocks, but we also looked for the interaction between our blocks. Okay, so bear that in mind if you do two-way ANOVA with replication. You need to look for the significance of the interaction between your blocks.